we'll be entering a new type of factoring pretty soon, but we're just going to talk about kind of the basics today in this lesson. So this is factoring using the greatest common factor. That's what the GCF stands for, in case you don't remember. So this is factoring using the greatest common factor. So you might remember the distributive property. It was the way we could multiply a polynomial, meaning something with more than one term, by a monomial, meaning something with just one term. So in this case, this example, this is the monomial, one term. This is the polynomial that has more than one term. So remember, we would multiply by the first term and multiply by the second term. Then 2x times x is 2x squared. 2x times 3 is 6x. So what we're going to be doing today is basically, instead of starting here and ending here, we'll start with this and move backwards toward this. As far as why we would do such a thing, that'll become more clear as we go through the course. But as you know, numbers have factors. We've done factor trees. You figured out prime factorization. 6 has two prime factors, 2 and 3. And 6 is the result of multiplying these two factors together. So 2 times 3 is 6. So we've factored numbers before. But it turns out that expressions also have factors. So as you can see above, what we ended with, 2x squared minus 6x, has two factors. That's what we started with. These are the two factors of 2x squared minus 6x. And just, this is a hyphen, not a negative. So I'm saying the two factors are 2x and x minus 3. And just like 6's factors, 2 and 3, when you multiply they give you 6. These two factors, 2x and x minus 3, when you multiply them together, you get 2x squared minus 6x, as you can see what we did up here. So when we multiply the two factors together, we got the expression. So factoring an algebraic expression is working backwards to find its factors. So we'll start again with 2x squared minus 6x. So to factor, what we have to think is, what do these two terms, 2x squared and 6x, have in common? And you want to think about what they have in common, both as far as numbers and as far as variables. So both of these can be divided by 2. So 2 is part of their greatest common factor. And both of them have at least one x. So they both have, we can divide them both by 2. That's something that goes evenly into both numbers. And they both have at least one x. So their common factor, their greatest common factor, is 2x. So we can basically do the distributive property backwards to find out what these factors are. So here's the idea. We start with 2x squared minus 6x, and we say, okay, what do they have in common, which we talked about up here. They're both divisible by 2, and they both have at least one x. So we will divide 2x, or pull 2x out from each one of them. So if you pull 2 and x away from this one, it leaves just one x behind. Because there were two x's, x times x. We took one of them out, so there's one x left behind. Now here, 6 divided by 2 is 3, and we pulled that one x outside, so then it's just a 3 left over. So I'm going to give you a second to look at that, make sure you follow what I'm saying. Because we're factoring out, which is kind of like dividing. If you think about it, the distributive property is multiplying. So factoring is kind of like dividing, because we're saying, okay, both of these have a 2 in them, both of these have an x in them. So I'm going to divide this by 2x by pulling it out front. All that leaves behind is x. Divide this by 2x, which removes that x entirely, and 6 divided by 2 is 3. You can see we really do have the same thing we started with, because 2x times x is 2x squared. 2x times 3 is 6x. Now once we pull that out, we say, okay, we now have these two terms. They both have a 2x. So I'm going to pull that 2x out in front of both of them, and then what's left over is x minus 3, which we have right there. So once you find the greatest common factor and pull it out front, you pull it out front, and what's left over, in this case x minus 3, is what you put inside the parentheses. And if you look back up, this is simply the reverse of what we did with the distributive property. What we started with and what we ended with have traded places. Okay, so let's just practice first finding the greatest common factor. We're not even factoring right now, we're just figuring out what do they have in common. So remember, it's called the greatest common factor because, for example, in number 1, all of these are divisible by 2, but that's not the biggest factor they share. You want to find the biggest number that can go evenly into all of them. So take a second to think about that. What the biggest number is that would go into all three, that would go evenly into 12, 18, and 36. It is 6. 6 is the biggest number that would go evenly into all three of those. Okay, now let's look at number 2. You want to look at both the numbers and the variables, but look at them separately. So here's what I mean. When I look at this first, we're just going to say, okay, what do 18 and 27, what's their greatest common factor? What's the biggest number that goes evenly into both 18 and 27? That would be 9. Then we look at the variables. So they do both have y's. This one has 1 y and this one has 2 y's. And by 2 I mean it's y times y, because that's what y squared means. But we can only take out as many as they each have. So this one does have 2, but I can't take 2 away from both of them. So I can only take 1 away from both of them because this one has 1, this one has 2. So whenever there's multiple exponents, you always pick whatever the smallest exponent is for that variable. So we can only take 1 y away from both of them. So 9y is the greatest common factor. Again, when you have variables and you have different exponents, always go with the smallest exponent, because we want to know what we can take out of each of them. I can't take 2 y's away from this one, it only has 1. I can take 1 or 2 y's away from this one. So that's why I just take away 1, because that's the most I can take from both terms. So to factor out the greatest common factor, we do the distributive property in reverse. Once you've factored, if you want to, you can check your answer by multiplying, doing the distributive property, to see if you get the original answer back, original question back. I won't do that on all of these, but I probably will on the first one here. Okay, so we just talked about, on number 2, what the greatest common factor was for these two. Again, think about the number first, 9. The variable second, which would be y. So you got to think about this as division. So if I do 18 divided by 9, I get 2. And if I do y divided by y, it just cancels out. So all that's left here is the 2. For this one, I do 27 divided by 9, which is 3. And we took one of the y's away, but that would still leave one left over, giving you just y to the first. So this is the answer. This is the factored form of this. This has 2 factors, 9y and 2 plus 3y. And I'm not going to require you to check your answer, but I want to show you how you can by using the distributive property. So this is our answer. But if you want to check it, you can just do 9y times 2, which would be 18y, and then 9y times 3y. 9 times 3 is 27. Y times y is y squared. So you can see we got the same thing we started with, so that proves we did factor it correctly. Okay, on number 4, we want to first look at what number goes evenly into all three of these. So the only thing that goes evenly into 4 and 8 and 2 is 2. So I'll pull that out front to start with. Next we'll look at the variables. And let's just look at them one at a time. So A, they do all three have an A. This one has 2 A's, this one has 1, this one has 1. So the most we can take out is 1, because that's the smaller amount these two have. They also all three have B's. B to the first, B squared, and B cubed. So the smallest value, smallest exponent of B is what we want to take out, which is B to the first. So you always take out the smallest exponent you see for each variable. So the greatest common factor for these three terms is 2AB. So first, with the numbers, just divide. 4 divided by 2 is 2. We're taking away one of its A's, so it has one A left over, but we took away its only B, so it has no B anymore. For the next one, we do 8 divided by 2, which is 4. We took away its only A, so it has no more A's. We took away one of its B's, so it still has a B left over. Then for the last term, 2 divided by 2 is 1. You can write a 1 if you want to, but you don't have to. I think I will. We took away its only A, so no A's are left. We took away one of its B's, so there's still a B squared left, because we took away one of the 3, so there's 2 left. And that's our answer. Now I'm not going to do it right now, but if you did distribute this back into these pieces, you get the answer we started with. And just, number 4, and you'll see number 7. Those are the harder ones. So there'll be plenty like 3, 5, and 6 that are smaller, but it is good to know how to do the longer ones like 4 and 7. Number 5, we look at the numbers first. So we got to think, what's the biggest number that can go evenly into both 21 and 15? That would be 3. Okay, this one has an A, this one doesn't. So we cannot take an A out. It's not something they both share. This one has a B, but this one doesn't. Same issue. B is not part of the common factor because they don't both have one. So 3 is the only thing they both share. So all we have to do on this one is say 21 divided by 3 is 7. And the B is just still there because we didn't take out any variables. 15 divided by 3 is 5. And the A is still there. And hopefully that one's simple enough you can look and see the distributive property would give us the same thing back. 3 times 7 is 21. 3 times 5 is 15. Okay, number 6. The number that goes evenly into both would be 2. And they do both have a C, but we can only take out one C because that's the most that this one has. We take out one C. 14 divided by 2 is 7. And we took away one of its C's, so we still have one C left. Now, I made this example on purpose because this next part is something that often throws people off. So what will happen a lot of times is people will say, okay, well, we took out the 2 and the C, so there's just nothing left here, and they just close their parenthesis and finish. That's not correct. We can't just make a term disappear. This is part of why I made sure to tell you factoring is like division. Because you're really doing 2C, this one right here, divided by 2C. And anytime you divide something by itself, what's left over is 1. So if you start with 2 terms, you should have 2 terms inside. If you start with 3 terms, you should have 3 terms inside. So there may be times the greatest common factor is identical to one of the terms inside. When that happens, what's left over is 1, because we're doing 2 divided by 2, that's 1. C divided by C is also 1. And 1 times 1 is 1. So make sure you don't let a whole term just disappear because it's identical to what you're pulling out. When they're identical like this, the result is a 1. Okay, last one. We want to think what number goes evenly into all 3 of these. That would be a 2. Okay, we see all 3 of them do have j's. We got to look at the smallest one, smallest exponent, that's this one. So we only take out 1 j from all of them because that's all that one has. They do all have k's. This one only has 1, so that's the most we can take out. It's k to the first, because that's all that one has. So with the numbers we just divide, 12 divided by 2 is 6. We took away its only j, but we took away one of its k's, so there's still 1 left over. Then we do 6 divided by 2 for the middle term. 6 divided by 2 is 3. We took away one of its j's, leaving 1 left over, but we took away its only k, so it has no k's. Two divided by 2 is 1. If you want to write the 1, you can. You don't have to. One of the reasons I made a point to do that back on this one was to help give you a hint that we'll need to have a 1 when they're identical, like I talked about number 6. But on one like this, it's truly up to you. If you write 1b squared or just b squared, those are identical. They mean the same thing, so it's fine either way. So 2 divided by 2 is 1. We took away one of its j's, leaving 1 behind. And we took away one of its k's, leaving 1 behind. And that is factoring using the greatest common factor.